Okay, for lesson 6, if you notice there isn't a 6-6 homework, it's because you're supposed to think about a strategy for handling every problem that comes your way that you may need to factor. So the first page of lesson 6 is kind of a summary of how to handle problems that come your way. So skill 1, it says use a strategy to factor polynomials. So basically, you can get a 2-term problem, you get a 3-term problem, and a 4-term problem. 2-term problem, just check for the GCF like you do for everything. And then remember, it's going to be a difference of 2 squares. If you have 2 terms and it doesn't immediately look like you have 2 squares, make sure you take out the GCF first, and then you should have 2 squares. Perfect square minus a perfect square. And then that's how you factor those, right? If you have this, that's prime and cannot be factored when it has a plus in between them. For a 3-term, if a equals 1 or there is no a that you see, that means because it's equal 1. So those are the guess and check, or trial and error, or whatever you want to call it. Make sure that your terms are in order, and then check and see if there's a GCF that needs to be taken out. And then these signs need to be memorized. Put them on a flashcard. Make sure you have them down. And then you are just finding factor pairs of C that can be added or subtracted depending on which one your answers are to each other to match B. And if A is greater than 1, if you can guess and check if they're perfect squares or they're both positive, maybe you could still guess and check. But otherwise, use the AC method, which turns a 3-term into a 4-term. And then how you do a 4-term is you start by dividing it in half, find the GCF of the front half, then the GCF of the back half, and then put it together. So that should be everything from the chapter. So let's practice a few of these. This one here looks very busy. Let's see if we can take a GCF out of it. I always start with the smallest number and see if the smallest number comes out of the rest of them. And it does. And there's a lot of letters going on here. Notice that it's a perfect square letter here and a square letter here. That is the proper order when you have 2 variables. So let's take the 4 out and see what we have left. I think it's 14. All right, we take out a 4, and we have a guess and check left because A equals 1. Our signs are plus in the problem, so they're plus in the answer. And then we look at C, and 49 is a perfect square. So I'm going to try a 7 and a Y. And you can FOIL these back to check, right? X times x is x squared. 7x plus 7x is 14. And then 7 times 7 is 49. So we're good. And the final answer is squared. I'll take this on the test, but I don't know if your homework wants it squared. So this is a 4-term, but don't forget you can still take out greatest common factor. Okay, so you're always looking for that first step of greatest common factor to come out. All right, take a 5x out of this, you get a xy left over, plus 3y minus 7x minus 21. All right, we look at the 4-term. There's a constant term at the end, So that's probably a good order to try. So let's go ahead and divide. Let's ignore this 5x for a minute just to get the greatest common factor out of the front half. Same over here. Pull out the 7. That works. So x plus 3, x minus 7, and then the 5x goes in front is the answer to that one. This one, there's a greatest common factor of 100. Take that out. What do we have left? Perfect square minus a perfect square. So square root of the first, square root of the last, and opposite signs. It doesn't matter if you put plus, minus, or minus, plus. All right. Wow, look at all this. I'm hoping there's a greatest common factor of all of these. There's a 3. Let's take a 3 out. How do we remember that 3 goes into 109? 1 plus 0 plus 8 is 9. 9 is divisible by 3, so therefore 3 goes into it. And they all have a y squared. They also have an x and a y squared. Three xy squared is coming out. 3 into 108 is 36. And there's an x squared left. Minus 13x plus 1. All right, so that one has a perfect square in the front and a perfect square in the back. So we can guess and check. If you don't notice that, you can do the AC method with it. Perfect square, root. Square root. 1 is a perfect square. 1 times 1 is 1. So when you square root it, it's a 1. And when there is a negative and then a positive, my signs are negative, negative. So my final answer is that. All right, now a warm up for what we're doing today. Other than all that other stuff, for the new information, this is a linear equation, x minus 5 equals 0. We solve this by getting x alone on one side. Hang on. To remember that we, let's see, for these you have to remember dear Charles moves in. Distribute, combine like terms, move by adding opposite, and isolate by multiplying or divide by same. And it's referring to their sign. So here I need x alone on one side, so I moved the negative 5 to the other side by adding its opposite. So when I added it down, it would be disappear, get 0, positive 5 on the other side. So this is all units. It's chapter 1. Yeah, unit 1. I think. Linear equations. Had the opposite. Isolate by dividing by the same. Right? 0 over 2 is a 0. Always move before you isolate. And frequently you'll have a fractional answer for these. Stick with it. All right, identify an expression or equation. We have been, all of chapter 6 has been looking like this. It's an that right there is an expression. This one, because it has an equal sign, is an equation. All right. When you have an equation in 6.5, we're going to learn how to take another step to get x equals something. Okay. An expression, you're done here when you factor something. There's nothing more to factor. But when you have an equal sign and equal plus 0 on the end, that means there's another step. Okay? So a linear equation is when you have x to the first power. And you're going to solve this and you're going to get x equals 5 over 2. That's one answer. When you have a quadratic, which is an x to the second, you're going to have two answers. Okay? I think we're going to do one problem that has an x to the third in its original problem. It's going to have three answers. For x, x could be a 2, a 0, and a 1, or something like that, or three different fractions. Whatever works in, remember how equations work. Whatever this side equals, it has to equal 0 for this to be equal. This side has to equal that side. Okay? So we're going to find the possible answers for x to make that true. 2, let me prove it to you. 2 times, let me put 5 halves back in for x instead of x. 2 times 5 over 2. Now remember how you multiply fractions across the top, so that equals 10 over 2 equals 5. And then 5 minus 5 from up there equals 0. So this is the solution, or the answer to what x would equal if you want this to be a true equation for this side to meet that side. Okay? This is a linear equation because it has one x. This is not linear because it has two x's. And this also, if you FOILed this together, you're going to get 2x squared. So that's also not a linear. What they are is a quadratic equations. Okay. They don't make a line. Linear equations, remember y equals mx plus b. That's a linear equation. The solutions literally make a line on a graph. Quadratics don't make a line. They make something called a parabola. And if you go on to 92, you'll be graphing those. Okay. Let me do the flow chart on this one. Students will be able to solve quadratics by factoring and using the product rule. Product rule says if one factor is equal to 0, then both multiplied together will equal 0. And we'll get into that when we have the equations. But this kind of complicated flow chart here is supposed to help you figure out what to do, because a lot of these problems don't look the same. So we want to know how to handle them, and just start by figuring out if the equation is equal to 0. If it's not, you have to do some things to make it equal to 0. If it is, you have to understand whether there's factors or not. If you have, in that last problem we had 2x plus 4 and x minus 5 equals 0. Yes, it's equal to 0. Do you have factors that equal 0? That's a factor. That's a factor. That's because this is my binomial is multiplied by this binomial. So yes, I have factors that equal 0. So if you have factors that equal 0, you can go right to the zero product rule. The zero product rule states that you have to set each factor to equal to 0 and solve for it. So 2x plus 4 equals 0, and x minus 5 equals 0. That's setting each factor to equal to 0. That's how I'm going to get two answers from this quadratic. Solve for your x, move, isolate, move. So in this case, x equals a, that had a GCF in it. Oops. That's okay. In this case, there are two different numbers that would make this side of the equation equal to 0. Okay, if you put a 5 in for x, you get 5 minus 5 is 0. 0 times anything is 0. Okay, you put a negative 2 in for this x, you'll get a 2 times the negative 2 is a negative 4, plus 4 is 0. 0 times whatever this would be 0. So that's how the factor rule works, okay? And this is an example of one that has factors that are equal to 0. What happens if I have 4x squared plus 3x plus 2 equals 0? These are terms. There are 3 terms that equal 0, not factors. So up here, when it says, do I have factors, you're going to go with no. And then you're going to check for GCF. No, don't have a GCF. Then you're ready to factor it. Okay, that'll catch you up to what that one looks like. And on this side, if you don't have your equation equal to 0, if you have x squared plus 2x equals 5, I don't have an equal 0, so that goes over here. Do you have all factors on one side? No, I've got terms on one side, so that's a no. And then it says properly move all your terms to one side, so the x squared is positive and 0 is alone on one side. So that means minus 5 minus 5. Whatever you do to one side, you do the other. You get x squared plus 2x minus 5 equals 0. Then I'm back over here again, okay, and I'm going to factor that next. So it's very important that you have 0 on one side when you're factoring. If you can recognize that the problem you have, look at this problem here. When you have a problem that looks like this and has an x squared, you handle them differently than if you have a problem with just an x. If you have like 2x plus 3x plus 5 minus 2 equals 0, the first step you're going to do is combine like terms. And you're going to get 5x plus 3 equals 0. Then you're going to move the 3 over, and that's how you handle linear equations. But when you're doing quadratic equations, the first thing you want to do is make sure you have everything on one side and you have all that equal to 0. So they're different than linear equations. Okay? All right. Let me erase all of this extra here. So if I need to refer to this, I will be able to come back over here and actually read it. All right. So this one has 2 factors equal to 0. This has terms equal to 0. So what you do first when you're factoring, is the equation equal to 0? Yes, it is. Do you have factors equal? Yes, I do. Then you're ready to do the 0 product rule and set each factor to 0. Each factor set to 0. Solve. These are now linear equations. It changed it from a quadratic to a linear equation. We do that by getting all the x's on one side and all the constant terms or numbers on the other side by adding opposite. All right, so this case, x equals 3/2 or negative 1/5. It's a quadratic. It's going to have 2 x's, okay? This one doesn't have factors on one side. It has terms. Is it equal to 0? Yes, it is. Do I have 2 or 3 factors? No, I don't. Do I have a GCF for that one? No, I don't. Then I'm ready to factor the polynomial, and then I use the product rule. So factor first. Oh, it's got a 4 in the front. Wait, I'm sorry. Probably should do the AC method with this. 4 times 4 times negative 3. AC method gives you negative 12. Factors of a negative 12 that add up to a 1. That's my B. Remember, that's my A. So A is 4, B is 1, C is -3. So A times C equals 12. Factors of -12 go in these lines. And since there's a positive and then a negative, then there's a positive and a negative. So I have factors of 12 that are 1 apart. So factors of 12 are 1 and 12, 2 and 6, 3 and 4. Factors that are 1 apart are 3 and 4. And if I want that to be a positive, then that's going to be a -3 plus 4 equals 1. So the 3 has to go here, the 4 has to go there. Notice I did all that and I still am lining it up the same way. Make sure I get my key out. Make sure I'm not messing anything up. So this new problem is going to be 4x squared plus 4x minus 3x minus 3 divided in half. It is now a 4 term. Pull out the GCF. X plus 1, x plus 1, -3. So x plus 1 times 4x minus 3. All right, and I'm kind of out of room here. What I need to do next is the zero product rule. Sorry, I have to go kind of up here for a second. X plus 1 equals 0. 4x minus 3 equals 0. So x equals a -1. Sorry, you can't even read that. X equals -1 or 3/4. Okay. Do the rest on another video.